Hello students, as you know CBSE has issued a new syllabus for 2023 and 24 session, and according to the syllabus in chapter 1, that is real numbers, previously there were 4 exercises and now you are having only 2 exercises. Now before starting this chapter, let me give you the basics of this chapter and then I am going to start the sums of 1.1. As you know, the name of the chapter is real numbers. What are real numbers? When you say real numbers, there are two parts. One is called rational part, another is called irrational part. So we can say rational plus irrational means real numbers. Now what is a rational number? A number of the form of p by q, where p and q are integers and q not equals to 0. Then this type of numbers are called rational numbers. Irrational किसको कहता है? A number not of the form of p by q, the numbers which you cannot write like this. कोई भी नंबर जिसको इस तरह से इंटीजर बाय इंटीजर नहीं लिख पाओगे, उस तरह का नंबर को कहा जाता है इरेशनल नंबर. फॉर एग्जाम्पल √2, √3, √5, पाई, these numbers are called irrational numbers. सपोज मान लो कि √2 I can write in the form of √2 by 1. Though it seems that it is of the form of p by q, but √2 ये इंटीजर नहीं है. इंटीजर किसे कहा जाता है? सपोज ये 0 है, 1, 2, 3, यहाँ पे -1, -2, these are all integers. √2 तो यहाँ पे नहीं है, that means √2 is not an integer. Since √2 cannot be written in the form of p by q, where p and q both are integers, so these numbers are irrational numbers. Again, these rational numbers are of two types. One is integer, second one is non-integer. Integers में again 3 parts are there. One is negative part like -1, -2, -3, 0, and positive part where 1, 2, 3, these numbers will be there. This type of numbers 1, 2, 3, 4, 5, these are called natural numbers represented by the symbol n. If we include 0 here, 0, 1, 2, 3, 4, then these are called whole numbers. So in integers there are 3 groups. One is positive, another is negative, third one is 0, and another part is non-integers. Suppose we have written numbers like 2 by 3 or 3 by 4, those parts which are fractional parts, they are called non-integers. Again, if we say in decimal format, if we are having numbers like 0.57, this type of numbers which is terminating, it has stopped, then this type of decimals are called terminating decimal. Suppose 2.512, here 12, this part is repeating. So actual number is 2.512, 12, 12 like this. Then these numbers are called non-terminating repeating decimals. In both the cases, we say these are rational numbers. And if the numbers are like this 1.01, 001, 0001 and so on, here neither terminating nor repeating, khatam bhi nahi ho raha hai, repeat bhi nahi ho raha hai, then this type of numbers are called irrational numbers. In next part of the syllabus, it is given fundamental theorem of arithmetic. According to this theorem, any composite number can be written as product of primes irrespective of the order in which they appear. So here 6 is a composite number, whereas 2 and 3, these two are prime numbers. So every composite number can be written as product of primes. This theorem is called fundamental theorem of arithmetic. In 1.1, first question is, express each number as a product of its prime factors. First part is 140. Now 140 we can divide by 2 because here last digit or the unit digit is 0. So this is divisible by 2. 7 2 ja 14, 2 0 ja 0. So 140 when divided by 2 it is 70. 70 when divided by 2 it will give 35. 35 is not divisible by 2 or 3, so we have to divide by 5. 5 7 ja 35. So 140 can be written as 2 into 2. Do bar hai, so 2 square, then 5 into 7. So this is the answer. In 1/3 part, it is given 3825. Let me show this one now. In case of 3825, since unit digit is 5, which is an odd number, so it is not divisible by 2. So let me try with 3. Now 5 plus 2, 7. 7 plus 8, 15. 15 plus 3, 18. Since 18 is divisible by 3, means I can divide this number by 3. So 3 1 ja 3, 3 2 ja 6, 7 8 22, 3 7 ja 21, 15, 3 5 ja 15. Now again try with 3. 3 4 ja 12, 3 2 ja 6, 1 15, 3 5 ja 15. Now 5, 6, 7. 7 plus 4, 11. 11 is not divisible by 3. So this number I cannot divide by 3. Now I have to divide by 5. 5, 8 ja 40. 25. 5, 5 ja 25. Again you divide by 5. 5, 1 ja 5. 3, 35. 5, 7 ja 35. Now 17 is a prime number. So further division is not possible. So we can write 3825 as 3 square into 5 square into 17, which is the required answer. I hope remaining sums of question number 1 you can do it yourself. In question number 2 it is given, find the LCM and HCF of the following pair of integers and verify that LCM into HCF equal to product of the two numbers. Let me show number 1, 26 and 91. Now here first of all we have to find the HCF and LCM. So we will prime factorize 26 and 91 separately. 26 we can divide by 2. 2, 13 is 26. Now 13 is a prime number. Further division is not possible. Now 91. 91 you cannot divide by 2 because here unit digit is 1, which is an odd number. So this number is not divisible by 3 or 5. So we have to divide by 7. 7, 13 is 91. Since 13 is a prime number, further division is not possible. So 26 can be written as 2 into 13 and 91 can be written as 7 into 13. So HCF of these two numbers, now 26 is 2 into 13, 91 is 7 into 13. Out of these sets of numbers, which is the common number? 13. Since 13 is the common number, so HCF is 13. Again in case of LCM, we have to write all the factors. जो number है सबको लिखना पड़ेगा. 2 है, 7 and 13 to 2, 7, 13, and we have to write the maximum power. Here power is 1, power of 2 is 1, power of 13 is 1, power of 7 is 1, power of 13 is 1. So if I write all the factors, that is 2, 7 and 13 along with the maximum power, we will get 2 into 13 into 7. If I multiply, it will be 182. So we got HCF 13, LCM 182. Now in the second part it is given, verify that HCF into LCM is product of the numbers. HCF into LCM. HCF we got 13, LCM we got 182. Multiply, you will get 2366. Again product of the numbers. Numbers क्या क्या था? 26 and 91. दोनों को multiply करो. If you multiply, then you are going to get 2366. Therefore HCF into LCM and product of the numbers both are equal, hence verified. In question number 3 it is given, find the LCM and HCF of the following integers by applying the prime factorization method 12, 15 and 21. Now in this sum we have to calculate HCF and LCM by applying prime factorization method. So we have to factorize this one first. 2, 6 ja 12. Again 6 can be divided by 2. 2, 3 ja 6. Since 3 is a prime number, so further division is not possible. Now you take 15. In case of 15, it is an odd number, so it is not divisible by 2. Let me try with 3. 3, 5 ja 15. 5 is a prime number, further division is not possible. In case of 21, if you divide by 3, 3, 7 ja 21. So prime factorization of 12 is 2 square, or you can write 2 into 2 into 3, which can be written as 2 square into 3. In case of 15, it is 3 into 5. In case of 21, it is 3 into 7. Now, in case of HCF, HCF में क्या करना पड़ता है? जो कॉमन है, कॉमन तीनों में क्या है? 3, 3, 3. So 3 is the HCF. Other than 3, nothing else is common. In case of LCM, you have to write all the factors 2, 3, 5, 7. Write 2, 3, 5, 7 along with their maximum power. In case of 2, maximum power is 2. So here 2 2 ja 4, 3 4 ja 12, 5 7 ja 35. 35 into 12, it will give 420. So here HCF is 3 and LCM is 420. I hope remaining sums of number 3 you can try it yourself. Number 4 में देखो क्या लिखा है? Given that HCF of 306 and 657 is 9, find LCM of these two numbers. In this sum it is given that HCF of these two numbers is 9 and we have to find the LCM. We know that HCF into LCM is product of the numbers. So we can write, we know HCF into LCM of two numbers. Remember that this rule is applicable when two numbers are given. So HCF into LCM is product of numbers. So here HCF is 9, LCM is not known, and product of the numbers will be 306 into 657. So in the next line you can write LCM equals to 306 into 657 divided by 9. Now this 306 can be cancelled by 9. 9 3 are 27. You are left with 36. 4 9 are 36. So you got 34 into 657. So if I multiply 34 into 657, then I am going to get 22338, which is the required LCM. Now in question number 5 it is given, check whether 6 to the power n can end with digit 0 for any natural number n. तुमको चेक करना है कि 6 to the power n, n का किसी भी वैल्यू के लिए 6 to the power n कभी क्या 0 से ख़त्म हो सकता है या नहीं. Suppose 210 is a number. This number can be divided by 10. 0 0 cancel. So answer is 21. So if any number, कोई भी number, if in the unit digit, if it is 0, that means that number is divisible by 10. Suppose it is 211. Can I divide it by 10? No. So that means the numbers which ends with digit 0, they are divisible by 10. If it is divisible by 10, that means it must be divisible by 2 and 5. Since 10 contains 2 and 5, so number must have factors 2 and 5. Then only the number can end with digit 0. Now 6 to the power n can be written as 2 into 3 to the power n, which can be written as 2 to the power n into 3 to the power n. So this number is divisible by 2 but not by 5. So it is divisible by 2. You can divide this number by 2. It is divisible by 2 but not by 5. But not by 5. Since this number is not divisible by 5, therefore it is not divisible by 10. It is not divisible by 10. And since number is not divisible by 10, so unit digit cannot be 0. Therefore it cannot end. It cannot end with digit 0. Because if it ends with 0, then it must be divisible by 2 as well as 5. It must be divisible by 2 and 5. This is divisible by 2 but not by 5. So 6 to the power n. N can be anything. 1, 2, 3, 4. Whatever you want you can place. But it cannot end with digit 0. Now question number 6 is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5, they are composite numbers. Let me show one out of these two. Now the first question is, what are composite numbers? Composite numbers are those natural numbers having more than 2 factors. Here question is 7 into 11 into 13 plus 13. Now we can consider 7 into 11 into 13 plus 13 into 1. From here 13 is common, so we can write it outside. So we are left with 7 into 11 plus 1. So it will be 13 within bracket 7 11 is 77 plus 1 78. Again this 78 can be written as 2 into 3 into 13. So instead of 78 I am writing 2 into 3 into 13. So we can write 2 into 3 into 13 square. Now as you can see there are 3 factors and including 1 there are 4 factors. Since it has more than 2 factors, so it is a composite number. In question number 7 it is given that there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? In this sum, Sonia takes 18 minutes for one round and Ravi takes 12 minutes. Now here we have to find that after how many minutes will they meet again at the starting point. For this we have to find the common multiples, and after finding the common multiples, we have to find the lowest one. So we have to calculate the LCM to find the time. So here LCM of 18 and 12, if you go for the division method, 2 9 ja 18, 2 6 ja 12. Now with 3 3 ja 9, 3 2 ja 6. So LCM of 18 and 12, it will be 3 into 3 into 2 into 2. 3 3 ja 9, 9 2 ja 18, 18 2 ja 36. That means after 36 minutes they are going to meet again. Therefore, after 36 minutes they are going to meet again. They are going to meet again. In 1.2, first question is prove that root 5 is irrational number. This type of sum we have done in class 9. Let me show it again. Here question is we have to show that root 5 is irrational number. Here we have to prove it by contradiction. So initially we will consider let root 5 be a rational number. So we can write let root 5 be a rational number. And since it is rational, so we can write it in the form of a by b. So we can write, let us consider root 5 equals to a by b, where a and b are co-prime integers, and b not equals to 0. Here we have taken co-prime integers, that means between a and b nothing is common except 1. So when two numbers are having no common factor except 1, those numbers are called co-prime. So here among a and b nothing is common except 1. Now if you square both sides, root over 5 equals to a by b. If I square both sides, you can write here on squaring 5 equals to a square by b square. So 5b square equal to a square. Now here 5b square is divisible by 5. 5b square you can divide by 5. Here 5b square is divisible by 5. Since this is divisible by 5, that means a square is also divisible by 5. It implies that a square is divisible by 5. And since a square is divisible by 5, we can write a is also divisible by 5. A is also divisible by 5. Clear? We can name this one, suppose equation number 1. And since a is divisible by 5, suppose 30 is divisible by 5. We can write 5 6 ja 30. So 30 can be written as 5 into 6. Similarly here it is given a is divisible by 5. We can consider any number c. When you multiply 5 with c, you are going to get a. So it can be written as a equal to 5 into c. Just like 30 equal to 5 into 6, we can write a equal to 5 into c. So let us consider a equals to 5c. If I square both sides, then it will be a square equal to 5c square. Now a square from equation number 1, it is 5b square. So we can write 5b square equals to 25c square. So 5b square equal to 25c square. So b square equals to 25c square divided by 5. 5 5 ja 25. So we can write b square equal to 5c square. Now 5c square is divisible by 5. That means b square is also divisible by 5. So b is also divisible by 5. That means a and b both are divisible by 5. Both are divisible by 5. Which contradicts our assumption. Because we have assumed that both a and b are co-prime integers, and here we found that both are divisible by 5. So a and b both are divisible by 5, which contradicts our assumption. So whatever we have assumed, it must be wrong. So our assumption was wrong. So our assumption was wrong, that root 5 is a rational number. So we can write our assumption was wrong, therefore root 5 is irrational. In the second question it is given that prove that 3 plus 2 root 5 is irrational. Like previous sum, here also we can consider let 3 plus 2 root 5 be a rational number. So we can write, let us consider 3 plus 2 root 5 equals to a by b. Here you can consider a and b are co-prime integers and b not equal to 0. Now we can write 2 root over 5 equals to a by b minus 3. So 2 root over 5 equals to, b is the LCM here, here it is 1, b divided by b 1 into a minus b divided by 1 b into 3b. So we can write root over 5 equals to a minus 3b by twice b. Now a and b are integers. Since a comma b are integers, so a minus 3b by twice b is a rational number. But we know root 5 is irrational, but root 5 is an irrational number. So we got an irrational number equal to a rational number, which is never possible. So we got an irrational number equal to a rational number, which is not possible. So our assumption was wrong. So our assumption was wrong. Therefore 3 plus 2 root 5 is an irrational number, because we consider this one to be a rational number, and if we consider rational number, then we are getting this type of statement where we are getting one irrational number equal to a rational number, which is not possible. So our assumption was wrong. So it cannot be a rational number, it must be an irrational number. In next question, that is question number 3, in the first part it is given that prove that the following are irrationals. Question is 1 by root over 2. Like the previous time, here also we can write let 1 by root 2 be a rational number. We have to show that this is irrational. We have to just take the opposite, that is rational number. So we can write 1 by root 2 equals to a by b, where a comma b are co-prime integers, and b not equals to 0. Now we can rationalize this one, 1 by root 2. If we multiply by root 2, it will be a by b. So it will be root over 2. Root 2 into root 2 is 2 equals to a by b. So root over 2 equals to twice a by b. Since a and b are integers, therefore twice a by b is a rational number, but root over 2 is an irrational number. So we got an irrational number equal to a rational number, which is never possible. Rational number which is not possible. Since we got this incorrect statement, that means our assumption was wrong. So we can write therefore our assumption was wrong. So 1 by root 2 is an irrational number. I hope second and third part of question number 3 you can do it yourself, and that's the end of this chapter. In the next video I am going to show sums of chapter 2. Thank you for watching.